Hi students, in this video we are going to solve a problem based on convolution of discrete time signals. So impulse response of LTI system is given. Which is h of n equals 1, 2, 1, minus 1, and input signal x of n is given. Which is 1, 2, 3, 1, and we have to obtain y of n. Using convolution. Now, first step, we need to plot the signals. But for plotting, I should know where is the origin. So if nothing is mentioned as far as the origin is concerned, the first element you take as the origin. So this is the instant where n equal to 0 for h of n. And this is an instant where n equal to 0 for x of n. So basically now I can consider here h of n is like this. It is starting at n equal to 0, 1, 2 and up to n equal to 3 elements exist. And for 0 it is 1, for 1 it is 2, for 3 it is 1, repeat, for 2 it is 1, and for 3 it is minus 1. So this is h of n. Similarly, I can get x of n. And 0, 1, 2 and 3. And the values are 1, 2, 3 and once again 1. So these are the signals now, and with the help of the signal we will do convolution. So step number 1 is we need to replace this n by k so that we will get h of k and x of k. So this is x of k, and we have a next signal which is h of k. Now second step, we need to do time reversal of h of k. To obtain h of minus k, so we have a signal like this. Now if I do the time reversal, this time it will be from -3 to 0, and we have signals like this. So now we will consider that n is equal to 0 also, because in the convolution formula, which will be like this: y of n equals summation k from -infinity to infinity x of k into h of n minus k. So in this formula, if I put n equal to 0, it will be h of minus k only. So whenever we will shift h of minus k, the first step it has to check for 0 shifting. That means n equal to 0. So n equal to 0, h of minus k will remain intact. So for this case, we need to do the multiplication of x of k and h of n minus k for n equal to 0. So it is very simple over here. Only one instant is there where signals for both these cases exist, that is n equal to 0. Remaining part, here it is 0, and for the positive k, for h of minus k it is 0. So in the end, the overlapping will be only once, and that is n equal to 0. So I can say now y of 0 equals x of 0 multiplied by h of 0, and the value over here it is 1, here it is also 1, so it's 1 into 1, so answer will be 1. So I can say now y of 0 equal to 1 for n equal to 0. If I'm not shifting the signal, still overlapping is there, and that results into first element y of 0 equal to 1. Now let's shift the signal to this side. That means a negative value of n. So let's shift it by 1 unit. So this time we will consider n as -1. So if n is -1, the signal will be delayed by 1 unit. That means it is shifting towards left by 1 unit. So I will get a signal which will span from -1, and it will end at n equal to -4. The values will be, this is 1, this is 2, this is 1 once again, and finally it is -1. So this signal I get, which is h of -1 minus k, for the shift which I have done in the negative side, and this we need to multiply if there is any overlapping in the x of k, whereas x of k is like this. Here it is 1, then 2, 3, and once again 1. So this is x of k. So for n equal to -1, I will get this picture. If we see properly, I'm not getting any samples common between them, no overlapping. So I can say over here, since there are no samples common, or you can say overlapping, in x of k and h of -1 or in general I can write, repeat, h of minus 1 minus k, hence I can say y of minus 1 is 0 for n. Now same thing will happen. For n equal to minus 2, n equal to minus 3, because I am not getting any samples common right from n equal to minus 1. So if this n equal to minus 2, minus 3, minus 4, so on, it will never have samples common between them. So what I will do now, instead of considering only a one sample, now I will consider if n is less than 0, that means negative shifting of n, all the time I will get y as 0. So right now let's continue it and say y of minus 1 is 0 for n equal to minus 1, but in general I can say y of n will have the value 0 for any n which is negative. So this is the most general statement, so that next time onward no need to check for any negative values, we will just focus on the positive values. Let's go to the positive value now. That means shift over here is now n equal to 1. So the signal that we have is h of minus k. This we need to advance, that means it is towards right by 1 unit, so that it will start from minus 2 and it will end at 1. So it will start from minus 2, so you'll get a signal like this. Which is h of 1 minus k, and this need to be multiplied with x of k, which has span from 0 to 3 with the value 1, 2, 3 and 1. So now we need to check the common samples between them. So this is a sample which is common, plus this is a sample. So now I can say y of 1 equals, straight away I will write the value 2 getting multiplied with the 1 plus 1 is getting multiplied with the 2, and if you solve you will get 2 plus 2. So y of 1 I am getting as 4 for n equal to 1. Let's quickly go ahead and do it for n equal to 2. N equal to 2, that means h of minus k I need to shift by 2 units to the right, or I can say this particular thing has shifted by 1 unit to the right. So we will get a signal like this. It will start from minus 1 and it will end at 2. And the values are minus 1, 1, 2 and 1. So this is h of 2 minus k. This need to be multiplied with the x of k, which will remain as it is. With the values 1, 2, 3 and 1 once again. So this is x of k. So here we need to check how many samples are common. This is a common sample. Then we have this also. And finally this sample. So if I use the convolution sum formula, I will get y of 2 as this value is 1, this value is 1. So 1 getting multiplied with the 1 plus 2 getting multiplied with the 2, and over here 1 is getting multiplied with 3. So it will be 1 plus 4 plus 3. If we sum this up, y of 2 we will get as 8 for n equal to 2. Let's go ahead for n equal to 3. That means I can consider this signal will be shifted by 1 unit to right. So we'll get a signal span from 0. Like this. H of 3 minus k, and this we need to multiply with x of k, which has span from 0 to 3 with the values 1, 2, 3 and once again 1. So x of k and h of 3 minus k, we need to check how many points are common. So here all the 4 points are common. So y of 3 is nothing but here minus 1, and for x of k is 1, plus here 1, here 2, here 2, here 3, and in the end 1 and 1. So if we solve, it is minus 1 plus 2 plus 6 plus 1, and I've got y of 3 as, if we solve this, it will be 8. Let's do it for n equal to 4 now. So this will be shifted towards right by 1 unit to have the span from 1 to 4. So somewhere here it is 0, which is not required. Here it is 1, 2, 3 and 4 with the values minus 1, 1, 2 and once again 1. So this is h of 4 minus k. This we need to multiply with x of k, which will have the span from 0 to 3. with the values 1, 2, 3 and 1 once again. Now the sample points are for the instant n equal to 1, for the instant n equal to 2 and for n equal to 3. So y of 4 we will get minus 1 into 2 plus 1 into 3 plus 2 into 1, which is minus 2 plus 3 plus 2, and solving this we will get y of 4 as 3 for n equal to 4. This we need to keep on doing till the time we are not getting sample points common between them. So let's go ahead for one more shifting n equal to 5. So n equal to 5, we will have impulse response with the span from 2 to 5. With the values minus 1, 1, 2 and 1. So this is h of 5 minus k need to be multiplied with x of k, which is having span from 0 to 3, and the values are 1, 2, 3 and 1. So sample points which are common are this. Which is y of 5, nothing but minus 1 multiplied by 3 plus 1 multiplied with 1. So it's minus 3 plus 1. Y of 5 is minus 2 for n equal to 5. N equal to 6 will be like this. The span of the waveform will be from 3 to 6 like this. Values are minus 1, 1, 2 and 1. So this is h of 6 minus k, and we have x of k spanning from 0 to 3 with the values 1, 2, 3 and 1. So here we are getting only one sample common. So y of 6 is nothing but minus 1 multiplied by 1. So y of 6 we will get as minus 1 for n equal to 6. Now obviously if I have n equal to 7, there won't be any samples common between them. Same is the case for n equal to 8, n equal to 9. So even if I take any value of n which is greater than 6, I will not get any samples common between them. Hence what I can say, for the instant where n is greater than 6, there won't be any samples common between them and y of n will become 0. So right over here, for n greater than 6, no samples from h of n minus k and x of k will be common, or you can say overlapping. Hence we can say y of n is equal to 0 for n greater than 6. So now finally we will get for y of n a sequence where we have calculated all the values. So y of n we will obtain as 1, 4, 8, then once again 8, 3, -2 and -1. Since both the signals are having the origin at the first instant only, hence y of n will also have the origin at the first instant. So this is a complete answer using a convolution sum formula. Let's verify it with a matrix method. So what I will do, I will consider x of n in this column and h of n in this row. So x of n will be having 1, 2, 3 and 1, whereas h of n is -1, 1, 2 and 1. Now we need to find out the values after multiplying 1 with this, 2 with this, 3 with likewise. So we will get the answers over here: -1, 1, 2, 1. Then over here -2, 2, 4, 2. Then next is -3, 3, 6 and 3, and finally -1, 1, 2, 1. Next step, we need to segregate this. So if we solve, we will get -1, -1, 1, 7, 9, 5, 1. Now let's verify our answer with the matrix or tabular method. So in tabular method, we will consider x of n column wise and h of n row wise. So I will write here the sample points which are given x of n. So it is starting from 0 and have the values 1, 2, 3 and 1. and h of n impulse response of a system having a value 1 to 1 and minus 1. Now let's solve this. So it will give 1 multiplied with this row will be 1, 2, 1 and minus 1. 2 multiplied with this row 2, 4, 2, minus 2. Then 3, 3, 6, 3 and minus 3 and once again 1. So 1, 2, 1, minus 1. So if we consider elements in kind of a diagonal manner, we will get this particular structure. And now over here we can say y of n, which is nothing but a convolution of x of n and h of n, as here the element is 1, comma 2 and 2 get added, becomes 4. So what we are going in the end, we are just adding this. With sign. So if we add this 2 and 2, 4, 3, 4 and 1, which will give you 8, and 1, 6, 7 plus 2, 9 minus 1, 8, 2 plus 3, 5, 5 minus 2 is 3, 1 minus 3 is minus 2 and in the end minus 1 as it is. So this is the answer we are getting with the tabular method, and now we need to decide where will be the origin. So this x of n is started from here and h of n started from here. So this is intersecting the first element. Hence this will be our n equal to 0 in y of n. So this answer we got with the help of tabular method, which is same as the convolution sum formula. So we have verified our answer, and the answer that we obtained with the convolution sum formula is correct. Here is the end of a problem. Thank you.